Hello to everyone interested in our Cardano Project Catalyst Fund 2 experiment. My name is Jesse Lau, President of the RINA user group. This is the review and wrap-up of our successful Ouroboros over RINA project. The proposal was to connect a mainnet stake pool block producing node and relays through a RINA software stack in March 2021. We want to thank Project Catalyst for accepting our entry and the community for then selecting our proposal out of many to meet the Fund 2 challenge goals of encouraging developer and user adoption. We aim for our efforts to do both for Cardano and RINA, as scalability and adoption for both can be intertwined. If you're seeing it for the first time, RINA is an acronym for Recursive Internetwork Architecture, an experimental communications protocol that could improve the way the world connects. In a popular 2017 whiteboard presentation, Charles Hoskinson talked about the importance of RINA. Why it is so important is a long and technical journey into the future, but infinite scaling and better security potential is the surface summary. If you would like to learn more about it or participate, please read John Day's book, Patterns in Network Architecture, A Return to Fundamentals. Check out the Arati and Arlite RINA software stacks on GitHub, and visit our website, rinauser.group, or hit us up on Twitter at user_RINA. We're a diverse group of IT pros that meets every Saturday afternoon in Okinawa, Japan to discuss RINA use cases. Originally and currently sponsored by GLBB Japan, a communications service provider with the shared goal of investigating RINA as a secure, scalable network solution for the Internet of Things, out-of-band management, financial services, and more. Our group just celebrated its first anniversary. Things have moved along quickly, and here's a brief rundown of our timeline. In mid-August 2020, GLBB Japan hired its first Linux programmer to focus on RINA. August 22nd, 2020, we held our first RINA user group meeting, and in early October 2020, some of our members first began experimenting with Cardano stake pools on the testnet. And October 24th, 2020, our introduction video was posted up on YouTube, channel named RINA User Group. And November 5th, 2020, it was an honor to be contacted by Ludovic Bouvier from the Poisson Society to discuss RINA. November 15th, 2020, our technical director, Gary Blankenship, went on the Big Pay podcast where they talked about the Cardano Ouroboros Chronos white paper concept and its possible implications outside of Cardano. January 13th, 2020, our Project Catalyst Fund 2 win was announced. Thank you to the community for selecting us. Our server was also rack mounted on this day. March 2nd, 2021, GLBB fully deployed 4 Dell PowerEdge 640s in Tokyo for RINA development. March 15th, 2021, our ticker RUG mainnet stake pool came online, and on March 30th, it minted its first block. April 7th, 2021, the first draft of our paper was released on our website, rinauser.group, and April 15th, 2021, myself and our technical director, Gary, appeared on the IOHK Project Catalyst Town Hall YouTube video to announce our successful stake pool launch. May 15th, 2021, IOHK announced that we were selected to receive the large staking delegation, and June 5th, 2021, 3.29 million ADA was officially staked to the ticker RUG from IOHK. Thank you for that. This program really helps out small stake pool operators. August 13th, 2021, the 100th block was minted on our pool. Now, in retrospect, we were pleased with the results of the experiment. Lots of challenges along the way, but we were able to successfully keep to our schedule and achieve our stated Fund 2 goal of running the world's first Ouroboros stake pool over RINA. As for the lessons learned, we encountered some minor stability and reliability issues with the current software stack, which were also highlighting our lack of alarms. Initially, we attempted the Arlite software stack, but it was old and at the time only supported up to kernel 4.13.10. Then we attempted the Arati software stack, which we got working, but it was crashing far too often to be viable. We then went back and updated the Arlite stack ourselves and got it to work with kernel 5.4.0, and we got it reasonably stable. Then we deployed it on the testnet and eventually the mainnet. As for the physical infrastructure, as you can see in figures 1 and 2 of the Ouroboros over RINA paper on our website, rinauser.group, our current live setup is running inside 2 data centers in different locations within Tokyo, Japan. We have installed 1 node and 1 relay in each of the data centers. 10 gigabit per second DWDM links are used between the relays and nodes, both locally and with leased circuits between the data centers to establish connectivity. While we physically set everything up to run a closed network fabric, we were only able to make the second node available as a manually switched backup due to limitations with both R-Lite and Ouroboros. The first issue that we encountered once the system came online was during epoch 257. A time sync problem was exposed. The NTP network time protocol could not sync the relay and node through the RINA diff because it was designed to run on IP. In our solution, the relay NTP now passes through the RINA interface by modifying the NTP application on the relay and core nodes to replace the existing socket with a RINA socket. Since epoch 258, there haven't been any more timing issues. During the same epoch, we also noticed that the allocated 50 gigabytes of free space was running at 65%, so we decided to expand this to 200 gigabytes on all 4 servers. The second issue that we experienced was during epoch 264 because of virtual machine crashes with CPU and RAM overload on both the relay and core nodes. Initially, we were concerned this may have been an attack, but it was due to an updated Ubuntu kernel component which bugged, causing a buffer overflow. To resolve this, we containerized the kernel components related to the bug and restricted some of its syscalls. The third and final example was a minor error causing an outage that happened during epoch 280. Our lack of alarm and resulting slow response was the greatest concern here. Since then, we now monitor IP traffic flow data to and from the relays, alerting us on both high and low traffic thresholds as a custom solution because traditional alarms are not available over our RINA diff. To audit and troubleshoot our RINA implementation using Wireshark packet captures, we developed a custom EFCP packet dissector plugin so that Wireshark can analyze, sort, and display RINA. We have a zip file available on our website, rinauser.group, with README instructions, packet capture PCAP file, the necessary plugins, and also videos of the packet captures and flow data pictures for quick access. We now believe all of the issues that are unique to our RINA deployment are solved. However, we feel the overall stability of the software stack remains a concern, and based on this experience, a large-scale rewrite of the RINA stack would most likely be the best approach. For some perspective, Irati has several multi-million-dollar projects and still needs further development. Even though we are confident in our abilities and new ideas for the space, as a small group of volunteers without a significant increase in resources and time, this is currently a bit out of reach and scope. Moving forward, now having tested the limitations of open source RINA software, we'll now be focusing on combining hardware and software with P4 programmable network function virtualization for RINA and other purposes. We have 2 programmable ASIC switches on the way for testing, but we'll soon be searching out additional use cases and funding sources for experimental hardware and software development projects to interoperate native RINA with the existing internet. In closing, although we are finished with the software development for this project, we have plans to maintain our stake pool ticker RUG as it is, continuing to use our Fund to Award as the pledge, while also developing a reward system using smart contracts for our members' future participation, administration efforts, and innovations. Thank you to everyone at IOHK and the community for providing support and inspiration for our group's first real-world RINA use case. Once again, if anyone would like more details about the project, please visit our website, rinauser.group, where you can find our Ouroboros over RINA paper, PCAP with flow data, and our contact form. Thank you.